All right, so moving on to the next chapter. Looping, the kind of thing that I bet you already know how to do from taking fundamentals or scripting or Java or anything like that. You know what a while loop is. You know what a for loop is. We could just, hit the page down button and say we were done with it. But we're going to try to eke out some good stuff out of it nonetheless. For one thing, not every language supports the do loop. And it's always good to have a reminder of how to use nested loops and do accumulation of totals. But I want to veer off slightly first and talk about the idea of structures, because we're not really doing object-oriented programming yet. And I mean, we're using objects whenever we use, something like console.out, console.in, but we're not making our own yet, really. So I'm going to go ahead and make a...
You mean C++?
Yeah, why don't I get out of C++? I mean, they're kind of similar, but it'd be good to be in the right one. Thanks. So CS_Lecture K. So what is a structure? Well, Java doesn't have them. But you can simulate a structure in Java just by making a class that has no methods, no functions attached to it. It's just data only, or at least it should be. Same for Python. Python supports classes. And if you want to make a structure, you just leave the methods off. And the way that looks is something like this. Struct. I don't know why I capitalized the first one. Struct, and then let's give ourselves like a name. Patient. And an open brace and a closed brace. And what you do is you list the pieces of data that are important to you. Like, every patient has a height in inches, height_in, and every patient has a weight in pounds. I don't know, hospitals probably use kilograms and centimeters nowadays, but I don't know. I haven't looked at any hospital forms recently. I bet you could tell me, Denise. So, now we have this, and what is that good for? Because previously, all we've been able to do is use single pieces of data. Like we might ask for somebody's, height and their weight, and we might use some formulas to do something, but instead, now, and let's also throw in age for some reason, double space age. We've got three things we want to keep track of. We would have to keep track of those separately using the procedural programming that we've been doing in the prior weeks. But now we have a structure that can represent a cluster of data so that we can give one variable name to all three pieces of data. Like this. Patient P1, and then P1. What do you know? Uno momento. So the syntax is very similar to how you do it in Java, just about identically. Unlike C++, where this is enough to create a structure, to create an object, we have to use the new operator, new keyword, to create one. So this is a new patient. And then we can set those variables. P1 dot, no, P1 arrow. Why is that still not working? It's ticking me off. All right, the reason I stumbled is because I thought it was more similar to C++ than Java. Surprise, C# being Microsoft's essentially their own version of Java, borrowed a lot of the Java syntax. So we need to make every element in here public. Now what fooled me is that in C++, every element, every instance member of a C++ structure is public by default, but in C# they're private. So I'm going to do private double height _in, public, and then public space double. I'm just adding the word public in front of all these guys. And now when I go down here, I can get a hold of them. P1 dot, there they are, height IN. Let's not bother asking for input each time. So patient's 72 inches tall, P1 dot age, the patient's 30 years old, and P1 dot weight, they weigh 190. And then we could create a second one. Patient P2 equals new patient. Parentheses in parentheses. P2 dot height. This patient's a little bit shorter, 60 inches. P2 dot age. They're a little bit older, 40. P2 dot weight. They're a little bit lighter, 150. So now we have two variables that represent three pieces of data rather than just one. And that's kind of nice, because we could write a function, we could write a method that would accept a patient as an argument, and then just one argument is feeding that function, that method, three pieces of data, or as many as we stuff in here. Right? A patient might have a birth date, an address, and all sorts of medical information about them. This is just, a single example. So if we are curious, we could try to figure out how big these objects are using the size of function. Something like this. Just out of curiosity, CW tab, size of, parentheses, patient, in parentheses, in parentheses. Oh, and you're going to underline me, aren't you? Okay, it says on an unsafe context. I may have to get rid of this. Yeah, forget that. Okay, so we're not going to do that. I put this structure in the same namespace as our class. We could actually even move it to be inside the class itself. If we weren't going to access it, we could move it down in there. But to me, it makes sense to make it not part of the class, but to leave it as something separate. So let's write a method that accepts a patient and prints it out. Then we'll be done with structures for today. So public, static, void, just because it doesn't need to return anything. Print underscore patient, and it's going to take a patient as an argument. Patient space P. And we're just going to use console.out.writeLine to print some stuff, right? CW tab. Let's write the patient's weight. Sure would be nice if we'd stuck name in there, right? We don't even have their name. We don't even know who this patient is. So I'm going to go and modify the patient structure to throw a string in. Public string name, semicolon. So I modified our patient class. Excuse me, I called it a class, naughty me. It's a structure. Conceptually, the difference between a struct and a class is that the structure should not have methods, should not have functions attached to it, whereas a class does. All right, everybody got that part? Got that added to it? I don't want to go too fast. I better stop and walk around as soon as I do this very next thing. Okay, so where we created the patient, I'm going to set their name. P1.name is equal to quote Bob, end quote. So I just added that statement, as well as adding their name. Whoops, this isn't Python. We don't use that as our symbol, comment symbol. So I just added, and don't add these. These are just to mark off the changes that I just made. The name, we want to fill it in for patient 1. And the name, we want to fill it in for patient 2. So after we create patient 2, p2.name equals Carol, end quote, semicolon. And just to make things a little bit easier to read, I'm fond of white space, so I'm going to hit enter right there. And just to get it to the point where it will compile again, because right now I've broken it by having this incomplete statement, I'm going to make the print function just print out their name. That's enough. So right line, parentheses, quote, patient, space, end quote. Let's do our normal stuff. Curly brace, 0, end curly brace, end quote, comma, p dot name, in parentheses, semicolon. All right, it should compile now. I just wanted to get it back to a point where it would compile. And then I haven't even called the print patient function, so it's not going to do anything. So I'm going to call it print underscore patient, and I'm going to pass in P1. So this argument is going to fill in this parameter variable so that we can print that information out. Let me make sure that works, and then I'll wander around and pause and make sure everybody gets a chance to type it in. And what did I forget to do? I forgot to put my write line in it. Excuse me, my read line at the bottom. So I'm going to do start without debugging, so it pauses at the end. I think it's insane that doing it with debugging doesn't make it pause, and without debugging does. It seems the reverse to me. Okay, but it did print out Bob. In a minute, I'm going to scroll down, and add my read line or read key just to keep it on the screen. All right, so wandering around helping, I've noticed that one student's version does something different than the others, which is display some warnings. So even after you correct all the errors, it displays some warnings. One of the warnings is that C# really wants you to capitalize your method names, your function names, whereas most other programming conventions, like for Java and Python, want you to leave it lowercase. C#'s programmers want you to uppercase the method names. And we see that, like that, right line, got a capital letter. We could abide by that, or you can just ignore the warning. Then I can't give you a good reason to uppercase your, initial cap, your method names, except to make the warnings go away, and also to be more, like other C# programmers to imitate them. And so, yeah, you could. Now, the other paradigm that most of those other languages follow is that the only things you uppercase are the names of structures and classes, and that everything else is lowercase. And if you were programming in Java, it would not be console.writeLine with an uppercase W, it would be with a lowercase w, to abide by that. But to go with what C# wants, what Microsoft likes, I'm going to make this look a little bit more like a Microsoft written code by putting an uppercase letter there. See, I think that makes it harder to read. I like my underscores, but they're old-fashioned. They fell out of favor in the 80s. Okay, and so now it says print patient without the underscore, and it's got its capital letters. And so after I make that change, if you're feeling like doing it, you're going to need to make your call the same way. Print, remove the underscore, patient. Now you don't have to make that change. It worked just as well, but it got rid of one of the warnings. Another warning that student's Visual Studio is saying that this parameter is not being used. Well, yeah, no kidding. So what does it want us to do? Delete it? Let's see if it'll even compile if that's deleted. Yeah, sure enough. Okay, so if you're getting a warning about that, the parameter not being used, you can remove them. We haven't even talked about what this is for because we haven't talked about arrays yet. So you could conceivably get rid of that. And the third thing it's arguing about is the fact that this new patient is unnecessary. We could have just done the C++ convention and created the object like that rather than calling the new operator. This is the Java style, like that. This is the C++ style. It supports both of them. If you're getting that warning, feel free to go ahead and just declare your objects like that. Right? You don't have to do the new operator, apparently. So maybe I'm going to simplify my code to make it look a little bit more like what C# programmers would write rather than what Java programmers would write. So I just took out the new operator business. And now all the warnings would have gone away if I was getting them to begin with. If you're not getting those warnings, yeah, blow it off. Or if you want to make the changes necessary to make them all go away, that's also fine. All right, that's about enough of structures, but we have at least introduced a concept. One more thing I want to mention is that C# is doing pass by value, what is also called pass by copy. Meaning, you know, this structure here, since it's got 3 doubles and each double takes 8 bytes, it's got 24 bytes of data, not even counting the string. Let's pretend that's another 8. So total 32 bytes. Each patient takes up 32 bytes. And when we call the print patient method, almost a tongue twister for me for some reason, it copies all 32 bytes into it. It creates a new object, copies all that data into it. You can improve the efficiency in a way that you cannot do in Java or Python by passing in a reference instead. Now, a reference means that you're not copying in a copy of the data, you're actually copying in the data itself. To do that, you would just add the word ref there. Now that breaks this because it also wants us to add the word ref there as well. So what that means is that we're getting a savings of processing time because it's not having to create a new object and copy those bytes in, and a little bit of efficiency because it's not having to copy the bytes in, right? So it's a little bit more efficient to do it that way. So you'll see a lot of C# programmers do it that way. On the other hand, it's throwing in a keyword that we don't know what it means yet. You know, we haven't really talked about reference versus, you know, pass by copy. But a reference just means that it's actually copying in the variable itself. Rather, you know, it's like instead of me giving you a photocopy of $1, and you can do whatever you want with a photocopy, you're getting my actual dollar. So in that case, this would need to be a little bit more careful not to play with the data and make any changes we didn't want to make to it. Hey, I don't know if I'm going to keep that, but maybe I will, just so that you'll be used to seeing it. Pass by reference for efficiency. Enough of that. You see what we've done with structures. We're passing around 4 pieces of data in one variable name. Can be useful because you could put 400 pieces of data in here. You could put, you know, arrays with thousands of pieces of data in it. You could, you know, embed structures within structures. You can make very complex things that you're allowed to just pass around with one variable name. I think that's enough of an introduction to the idea, but if we keep touching upon it, then it'll get lodged in your head really well.
Can you do that for the second patient?
We didn't call print, but yeah, let's print out the second patient as well. So let's copy that statement and paste it so that we print out patient 2. And we didn't print out any more information except for their name. That's kind of lame. I was in a hurry. So why don't we, after you copy and paste that print patient reference, method call, let's come up and add a little bit more information to it. I'm awfully fond of copy and paste, so I'm just going to copy that entire right line method, paste it, patient, and I'm going to make this say patient height, and change this to dot, whatever it needs to be, dot height underscore inches. I'm going to make this say patient weight. So I'm just adding some words in front of our curly brace placeholder, and I'm changing which variable, which field we're printing out. And that was supposed to be weight underscore LB. And this last one is their age, patient age. And so P dot age. If you're wondering how I'm typing it so fast, I'm just going back to the P, and I'm typing in the dot again, and I'm taking advantage of the fact that it pops up a list of all the members. All right, now when we run it, we're going to get more interesting output. I still forgot to add my read line. Go down to the bottom here, above the third closing brace, console.readline or read key, doesn't really matter which one. We could put a print statement that said hit enter to finish, you know, if we felt like it. CW tab tab, press enter to quit or whatever, to exit. Now we're good to go. Now I don't have to be annoyed that it keeps closing my window. All right, there we go. Bob, 72, weighs 190 and is 30 years old. Carol, 60, 115, 40. So we've written a method that will accept a patient structure, an object, and then use it. So we only had to pass in one piece of data in order for it to have access to 4 pieces of data, because the structure is carrying around those 4 pieces of data. Gets a little bit more complex if we want to talk about the difference between an object and a reference variable that's holding a pointer to the object, and we'll leave that alone for now. Anybody need to see any part of this? Scroll up or down?
Just where you're at, but I'm still getting that error for some reason.
All right. To the PowerPoint. Loops. What is a loop? It's a body of code that gets repeated. So instead of just running from the top to the bottom, repeats it. So, for example, we can put a loop in here. Say we like Carol so much that we want to print her name 10 times. I mean, print her information 10 times. This is kind of silly, but why not? So let's declare a variable. X is equal to 1, int x equals 1, while, parentheses, x less than or equal to 10, in parentheses, open curly brace, print patient, parentheses, ref p2, end parentheses. Now remember, you only need this ref keyword if you declared it as a ref method up here. If you delete it from there, you're going to delete it from there. And then, if I did this, it would be an infinite loop. I'm going to go ahead and run it so that you see what happens. Right? That's not cool. The reason why is I never update x. So x is always less than 10. So it's like an if statement, right? If x is less than 10, go ahead and print it out. Except, once it hits the closing brace, it hops up here and it checks the condition again. Well, x is still equal to 10, so it prints it again. If this condition wasn't true at all, it wouldn't even do it once, right? So if I set x equal to 11, don't do this, I'm going to undo it immediately. It's not going to even print that patient out. Well, I mean, it did the first time, but it didn't do the loop, right? Because if this is set to 11, this isn't true, just like an if statement. If the if statement is false, it won't go into the body. All right, I'm going to change that back to 1. But to get it to work correctly, I need to increment x. So it won't just be the same forever. So x plus plus semicolon. Now we have our code that's going to print Carol's information out 10 more times. All right. Even more elementary. Let's write a loop that prints a number out. While, parentheses, x is greater than equal to 0, close parentheses, CW tab tab, x. Just print out the number x and then subtract 1 from x. X minus minus, semicolon. So that's going to print 109876543210. Why is it starting at 10? Actually, it might print 11. 11, 10, 9. That's actually what it's going to do. Yeah, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Why did it start at 11? Because it, yeah, Simon, I interrupted you. Because the only time it was able to exit from that loop is when x was 11. And so x was still 11 by the time we got here. What would I do without changing that while statement to get it to count from 20 to 0? Or from 10 to 1? Yeah, I want to change this code right here to make it print from 10 to 1. I might have to add a line of code to get that to happen, but what could I do? Yeah, if x is 11 by the time we're here, but we want it to start counting from 10, we just need to reassign it. And then if I want it to stop at 1 rather than 0, I need to change that line right there. Right now it's counting 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What if we wanted it to decrement by 2 each time rather than 1? Well, we could change this statement. We don't want to do that anymore. I want to count by 2's, so x minus equals with no space between the minus and the equal, 2 semicolon. Now to count 10, 8, 6, 4, 2, and stop there. Yep. 10, 8, 6, 4, 2. There's also something cool called a for loop, which you've used in other languages. We're going to ask the user for a number, and then we're going to print out all the factors of that number, starting at 1 and going up to the number itself. Nah, let's make it simpler. Let's just print a sequence of numbers out. Do the easy example first, and then make it a little bit more complicated. The cool thing about a for loop is here we have the initialization. This is the init stage. This is the compare stage. And this is the update stage. A for loop specifies all three of those in the very header of it. So for, parentheses, x equals 1, semicolon, x less than or equal to 10, semicolon, x plus plus. See, all three of those things, the initialization, the comparison, and the update are stated in one line. And then we could print that number out, right? CW tab tab x again. So that's a little bit easier, right? This took 1, 2, 3, 4, 5, 6 lines of code, or 4 if we, yeah, 6 lines of code. We could boil this one down to just 2 lines of code if we remove the curly braces, which would be totally fair because we don't need them now. We had to have them here because our body of code was 2 lines long. Take our curly braces out. Here. We don't need to do the update because the update's being done there. We don't need to do the initialization step because it's already being done there. All right, let's figure out the factors. The numbers that, the factors of 10 are 1, 2, 5, and 10, right? So let's ask for the number. CW, tab, tab. Let's calculate factors. For what number, question mark, end quote, parentheses, semicolon. Now for calculating factors, it may as well be an int because I don't know if you can get the factors of 12.7. So int space number equals, let's convert it, our input, convert dot to int 32 parentheses, and inside the parentheses console.readline. That just saves us from having to store it in a string and then pass it to the conversion function, but it's not ideal because we're not using, try parse, but a little bit easier to type, even if it's a little bit more difficult to read. Now that we have that information, we can write a for loop that'll go from 1 all the way up to number. So how are we going to check to see if it's evenly divisible by that number? We're just going to use modulus. Because 10 modulus 2 doesn't have a remainder. It's got a remainder of 0, so 2 does go into 10. It's a factor of 10. But 10 modulus 3 does have a remainder. The modulus 3 does not equal 0, so we know it's not a factor. So for parentheses, int factor equals 1, semicolon, factor less than equal number, semicolon, factor plus plus, I should have just called it I or something to make it easier to type, but we are actually going to use a good variable name. Then inside our curly braces, we're going to check to see if number modulus factor is equal to 0, and if it is, we're going to print it out. So open curly brace. If, parentheses, number modulus factor equals 0, enter, CW, tab, quote, we need a placeholder, curly brace 0 in curly brace is a factor of curly brace 1 in curly brace, end quote. And we need to fill in those two placeholders. So comma, factor, comma, number. Now if I haven't made any mistakes, then I should be able to type in something like 100 and it'll list all the numbers that multiply up to 100. Let's calculate factors. For what number? 100. 1 is a factor of 100, so is 2, 4, 5, 10, 20, 25, 50, and 100, right? Just like all the coins, you know, we have pennies and nickels and dimes and quarters, but a couple more. We don't have a 20-cent piece or a 4-cent piece. Yeah. All right, I'm going to run it again just to see what it does with a prime number. 11's a prime. And so the only numbers that are factors of 11 are 1 and 11. Now it's funny, when you count out your prime numbers, you know, the numbers are the ones that are evenly divisible by that number and 1. They don't count 1 officially as a prime number. Why? Because it only has one factor and not two. And so the definition of a prime number is a number that only has two factors. And 1 only has one factor. It's weird. To me, 1 would be a prime number too. But according to the guys who make the rules, I shouldn't say guys, you know, the men and women, the mathematicians who make the rules. All right, we're about done today. We've already gone over, or we already know what a loop is. We know what a loop body is. It's the block of code underneath it, right? You can start with a curly brace and end with a curly brace. The while word inside the parentheses has a Boolean expression that controls whether it keeps repeating or not. So the while loop consists of the keyword while, and then inside the parentheses there's a Boolean expression, and then after it's a loop body. An infinite loop is one that never ends because the loop variable never changes, or for whatever purpose the Boolean expression here never becomes false. X never stops being less than 10, whatever. So usually a loop has 3 different steps: where it is initialized, where it is tested with a comparison, and then something alters it. Now you can write loops that don't do all 3 things, like a while true loop, but this is your classic loop. Initialize it, test it, update it. And we had those 3 steps here. Initialize it, test it, I called it compare, same deal, and update it. It's your classical loop. For loops do the same thing. Initialize it, test it, and update it. These are called pre-test loops because the test happens before the body of the code. Some languages only have pre-test loops. Python only has pre-test loops. It does not have any other kind. So if this expression is false, it doesn't even go into it. It's tested before the body of the loop. It is pre-tested. And we see that here, right? We set up some values. The test happens, and then the body of the loop executes all those statements. All right, let's see if we have some pre-cooked home. Okay, so homework over this idea. And you don't have to type the homework assignment in, I always do, right? Write code that will ask the user for a starting number and an ending number, and will print all the numbers from start to end, right? So if they enter 10 as the start and 20 as the end, it will print, 10, 11, 12, etc. up to 20. If you're feeling really adventurous, make it support if they enter a starting of a large number. And it can count down, right? If you can, make the code support starting from a large number and going to a small number. If not, just print out an error message if the start starting point, if the start is larger than the end. Right, so if they enter 20 as their start and 10 as their end, and you didn't make it support counting down, just print out an error message. That's part one. Part two, write a loop that iterates, counts from 1 to 10, printing the squares. So it will print 1, 4, 9, 16, 25, right? All the square values. I'm not sure I'm doing this right. What is 7 times 7? 49. 8 times 8 is 64. 9 times 9 is 81, and then 100. You don't have to print them horizontally like that. Okay, so that's part one and part two. That makes sense, guys? So it's fun to see people's solutions for this part, to make it support going from a large number to a small number, because there's a couple different ways you could do it. And I'm not going to give you hints because I'm just curious. All right, again, that's enough.